Drought. This has now become a serious problem in many European regions. Measurements show that the groundwater level is falling dramatically. The MAURICE research project, launched in 2023, investigates the causes and develops strategies for conserving water, a vital resource. 4 European pilot projects are now presenting their results. Take Milan, for example. A huge network of irrigation canals for agriculture is in danger of drying up. The backbone of crop production in the Po Valley is at stake. The MAURICE project team has developed initial solutions. In winter, excess water from the Ticino River will be diverted to the irrigation canals around Milan. There it will be distributed to selected agricultural areas and will naturally seep into the ground. This will replenish the aquifer and help preserve the ecosystems that depend on it. During dry periods in summer, farmers can then use groundwater to irrigate their fields.
This solution offers several co-benefits. For example, higher irrigation efficiency, lower need for canal maintenance, and thanks to increased infiltration, the approach aligns with the sponge city concept, strengthening long-term climate change resilience.
In the Czech town of Nový Bíčov, those involved in the project are focusing on making rainwater usable. This is an important pillar for future water management. First measure, municipal recreational facilities such as swimming pools are already supplied with rainwater. This means that water is no longer being drawn from groundwater reservoirs. To this end, the city has installed a water treatment plant that filters pollutants from rainwater and feeds clean water into the swimming pools. The city no longer uses fresh water, thus adhering to the principle of prudent water management. A similar approach is taken at the ice rink. Here too, the city no longer uses fresh water, only rainwater.
Here at the swimming pool, we are testing a pilot technology, which we would subsequently like to use, and that is a technology that actually recycles water, which for hygienic and safety reasons must be pumped out and replaced from the pool every single day to ensure cleanliness and proper sanitation. The advantage of this solution is that this technology should save up to 70% of drinking water consumption for the pool's operation.
Take Ljubljana in Slovenia, for example. Here too, the city no longer wants to allow rainwater to flow unused through sewers, but instead wants to return it to deeper soil layers. The aim is to prevent residential and commercial areas from flooding during heavy rainfall. Flooding always carries the risk of pollutants contaminating the soil and subsequently the groundwater. With the help of infiltration basins, rainwater will now be directed into deeper soil layers. The city and the MAURICE team have therefore installed a first demonstration infiltration basin that has been created on soil with lower permeability. Test results will enable cities to assess infiltration capacities and mitigate stormwater runoff in areas at risk. The aim is to reduce flooding in urban areas as much as possible by installing numerous infiltration basins throughout the city.
We can plan resilient dewatering concepts in the city according to the natural conditions in the area and according to the expected effects of climate change. Now, it's no longer a question of whether infiltration is possible, but rather how much stormwater we can infiltrate, how much we can maintain in the natural water cycle, and how much stormwater can be reused. The
city of Jaworzno is increasingly facing the effects of climate change. Due to its mining history, parts of the city are particularly affected during prolonged periods of heavy rainfall and its aftermath. Historical, shallow, hard coal mining burdened the city with its consequences. Heavy rains cause serious hazards in post-mining areas, especially in highly urbanized areas, creating sinkholes. The MAURICE team is therefore working on blue-green infrastructure solutions to collect and retain rainwater and slow down its runoff.
This can be done through simple solutions such as creating rain gardens, building retention basins, or using permeable resurfaces. The idea is to allow water to infiltrate slowly and evenly rather than flow rapidly into a single point.
The team has set up pilot blue-green infrastructure composed of 4 test areas with different infiltration surfaces. These have varying degrees of permeability and are each equipped with a measuring system. The team wants to use this to find out how effectively each surface can retain and slow down water flow. Additionally, blue-green infrastructure solutions are intended to support local rainwater management and prevent ground destabilization. The recommendations will be transferable to other historical mining areas where the risk of soil deformation is possible. The MAURICE pilot projects serve as a reference for cities and regions in Central Europe on their way to sponge city implementation. Their goal is to combat climate change with smart water management. After all, water will be the most valuable resource in the future.